He comes from, in origin, from the Far East. He has some experience in doing some slams. Yeah, he took part in this famous from the British Council. Is a kind of slam. Yeah, it's Fab Slam. So, and these are a little bit different than this. They have only 3 minutes time, and they can't use a PowerPoint or nothing. So let's see what's coming up with this technology. Und freue mich jetzt schon auf Nicola mit Vasi. Viel Spaß. Have fun.
Hello everyone. So today we will go on a journey through history to talk about a very brave battle between our immune system and a formidable disease, which is cancer. Now let's go to a trip to ancient Egypt. You know, until the year 1799, no one could actually understand or read what was written on the walls of the temples of Egypt, or even read the manuscripts found in the cemeteries. This was a really big mystery. Until one day, what is called the Rosetta Stone was discovered, a key to unlock history. The Rosetta Stone had translation of hieroglyphics, the ancient Egypt language, into Greek. And that enabled a very smart scientist called Jean-François Champollion to crack the code of the ancient Egyptian language. You may wonder, how is that related to our topic? Well, with that achievement, we could actually understand one of the oldest medical files or manuscripts in history, dating back to the year 1550 BC. This papyrus or manuscript called the Epirus, and now actually it's in the University of Leipzig, it describes a physician called Imhotep. Imhotep found a fascinating observation. He saw that when he introduced incision in the tumor of his patient, which led to kind of infection, the tumor was shrinking. He couldn't understand what's happening, he couldn't explain it, so he wrote it down for the coming generations in order to investigate it. And now we were able to read it. Now let's move fast forward in time to the year 1891, specifically to the clinic of Dr. William Coley. Dr. William Coley at that year was devastated because he lost a young patient of sarcoma called Elizabeth. So determined to find a cure, he was looking into medical literature, into files, medical files, and what he found, some doctors reported that people who had infection at the site of the tumor was shrinking. And this is why he decided to test that himself. And what he did, he just took his syringe, filled it with some infectious bacteria, and start injecting it into patients. Back then it was easy. There was no FDA or EMA. You do whatever you want. So what he saw, that the tumors in some patients were actually shrinking, or in some of them were even disappearing. However, he had a hard time. There was a lot of backfire on him from the other scientists because he had some inconsistencies in the methodology he used or in reporting the results. Back then, you know, science was not like now. However, today, William Coley is recognized as the father of immunotherapy. And actually, I hope that one day we will have his name in one of the rooms in Miltenyi. Now, how can we actually understand or explain what Coley saw, what the ancient Egyptians saw? Nowadays, we know that we have something in our body called immune surveillance, meaning that there's immune cells patrolling in our body day and night, going up, down, left, right, everywhere, trying to observe, catch, and eliminate dangerous bodies like cancer cells, bacteria, viruses, whatever is foreign. And today we will focus on one specific type of immune cells, which is T cell. Now, T cells have their name from the university where they studied. So they studied in the Thymus School of Immunity. And this is where they develop, and they are able then to differentiate between self, non-self, good, and bad. So how does these T cells work? They have kind of a face recognition system or a danger recognition system called the TCR, or the T cell receptor. For this to work, it needs two things on the abnormal cells, like the tumor cells. And it's similar to a frame and a picture. So they need first a frame, which is called MHC, or major histocompatibility complex. And inside, they need the picture, or the antigen. Once you have this complex, they can actually recognize it and destroy the abnormal cells. So, the question now, if the T cells are so well trained in one of the best universities, so well educated, why they are failing to catch tumor cells in many cases? Well, the answer is cancer is very tricky, and it has many tricks to escape from our immune system. For example, it can downregulate the whole frame picture, this MHC complex, completely. Or it can even secrete some signals which would inhibit our immune cells, so they would go into sleeping mode. And here comes the role of immune therapy, or immune-based therapies, which is a field that aims to empower the T cells in order to kill and fight tough tumor cells. This is from Science magazine in 2013, where they called cancer immunotherapy as breakthrough of the year. And they were right. One of the best examples of immunotherapy known today is CAR T cells, or chimeric antigen receptor. And this is kind of a version 1 update of the original recognition system. So here simply, the CARs are kind of an additional arms, strong arms, expressed by engineered T cells, which can recognize some surface structures on the tumors. And here they don't need this MHC complex, or the frame picture I mentioned before. They can directly go to these surface structures, recognize it, kill the tumor cells. And I want to share with you one of the fascinating success stories. In 2012, a young girl called Emily Whitehead was suffering from leukemia. She went into conventional therapies, lost her power, lost her hair, her parents were devastated, until they informed them that she can go into a clinical trial as a first pediatric patient. She went into the CAR T-cell trial, and it was like a miracle. In a very short time, she improved, and she even was cured. So this was one of the best and amazing news back then. And today, Emily Whitehead is an adult, healthy, no signs of disease. She's studying at the university and promoting, actually, for CAR T-cell therapies. She's not the only one. Now, thousands of people worldwide are getting today CAR T cells, and they are getting cured. However, it's not all flowers, because T cells, they can become too excited. Well, sometimes here in the company, it's very good to become too excited for your work, but for T cells, that's quite dangerous, because they can develop really serious side effects. And these side effects can even lead to death, as what happened, unfortunately, in 2016 in one of the clinical trials. 3 patients died directly due to the CAR T-cell therapy. And this is why in Miltenyi, what we're trying to do is to do the update version 2 of the CAR T-cells, which we call adapter CARs, or switchable CARs. So these T cells, they cannot recognize anything by themselves, no tumor cells, no normal cells, nothing, unless we provide them with a key, or we call an adapter. This key would bridge both cells together, activate the immune cells to destroy the cancer cells. Okay, so what happens now if we have side effects and the patient is suffering? We simply discontinue, remove the key, and then the system will be switched off. And this is how we can have an improved safety, and we make sure that the patients are safe. Now, despite all the success story that I have mentioned, we are nowadays still struggling to fight tough, solid cancers and even some hematological malignancies. But I am sure we are on the right path. And hopefully, one day, maybe next year, in 10 years, 15 years, who knows, we will be able here at Miltenyi to say, cancer is history. Thank you very much.